All right. So today I'm going to present a new tool for MicroPython, which is an updated package manager. The idea is to provide an easy way to install both MicroPython lib packages, but also third-party packages onto both boards that have Wi-Fi and any board that you can communicate with via MP remote. That was kind of the big thing that was lacking before now, is that we would say, oh, here's this useful package that you can install from MicroPython lib, but it was never clear, especially for libraries that were more than one file, how to get them onto the board. So I guess I'll start with a demo. There we go. So this, I'm connected to a PicoW that already has MIP installed. So I'll just make sure it's connected to the Wi-Fi. And I'm going to use MPR. MPR in this case is an alias for MP remote. So it's not confusing. So I'm on my PicoW and I can import MIP. So MIP is frozen into the firmware by default on boards that have Wi-Fi or networking. And I can mip.install, say PyJWT. And it's pretty straightforward, really. It's a package manager, it installs packages, and it auto detects the destination path based on what's already in sys.path. And so /lib is already in sys.path. And it installs the latest version of PyJWT plus any dependencies. So in this case, PyJWT depends on HMAC. And the important thing that's kind of novel since the previous package manager, UPIP, is that it also grabs the compiled MPY files rather than the Python source files. So the result of that is that it both takes up less space on the file system, but also imports faster and has less memory overhead during the import process. And then of course I can import JWT. And for most users, that's kind of the whole thing. If they have a board with Wi-Fi, they can install packages. We can, but as well as that, you can also install particular versions. So you can specify a version number. There's only one published version of PyJWT, so that's not that interesting. You can also run your own index instead of using the MicroPython.org one. So you could, in theory, publish your own library of packages and then specify that with the index argument. That obviously useful for testing. I can run the server locally, but in the future we could imagine that other people might run their own indices. And obviously you can also install it to a different location on the file system as well. When you install a library, it's smart enough to realize, so if I'm installing HMAC, which we already got transitively through PyJWT, and it'll realize and not download the new version. For boards that don't have Wi-Fi, so if I now plug in a Pi board, so I've now got a Pi board 1.1 plugged in. I can use the package manager via the MP remote tool. So npm has a mip command, and mip has an install subcommand. And so in the same way, I can install PyJWT onto my connected Pi board. Importantly, this time I'm not on the device. I'm running this from my PC. And it does the same thing, figures out the path and the dependencies. I'll go into a couple of technical details. So in order to figure out what the MPY file, these are pre-cross-compiled on micropython.org, and so it's able to figure out using sys.implementation.mpy. It's able to use the MPY version on the device to figure out which version of the cross compiler needs to be used. So over time, we will publish multiple versions of of each MPY file, depending on the board version that needs to download it. There's a little bit more to that, but that's the basic idea. You can also, if you want to download library code for the purposes of debugging or improving it or working on it, you can also force it to install with no MPY, in which case instead it will grab the .py files instead. I'll give one other example. So something I think that's quite common for people to do is to write a library that maybe one day they'd like to put into MicroPython lib, or maybe they have no intention, and reasonably so, of publishing it to MicroPython lib, but they still want an easy way for people to install onto their devices. So what you can do as the author of a GitHub repository, let me see if I can do this quickly. So this is a demo repository, hypothetically for a driver that has not been written yet, and it exists as a package containing an init.py and a utils.py, and I have pushed this to GitHub, so you could access that. Well, I can show you. You could go to that on GitHub, but I've published a package.json file inside my repository, and I say that when someone wants to install this, here are the files you need, and here's how to get them. And it depends on collections.defaultdict and os.path, which come from MicroPython lib, and this is version 0.2. So back on my PyBoard, if I wanted to install this driver on my PyBoard, I can npy mip install GitHub jimmo /MicroPython. What's it called? It's an MLX thing here. And it'll install via GitHub instead of via MicroPython lib. And in what you're seeing here is that it's fetching the Python files from my GitHub repo, but then also fetching the dependencies from MicroPython lib, and for those ones it gets them as MPY files. Now you'll see I mentioned that it had a dependency on os.path, but what's actually going on here is that the main branch hasn't got that change, and so if I install it at a particular version, the devel branch. So you can also do versioning is the idea. You can either point it at a tag or a branch in your Git repo as well to do specific versions. And so if I now fetch that, then I would get the os.path dependency as well. So in summary, the idea is that for many users, they publish to MicroPython lib, but if you want to self-publish, there's still this mechanism to do so, and it's easy. You just have to literally publish to GitHub or any HTTP static content server. I will very quickly just run through how it works. When you install a package, what happens is you request PIV2 package, and then your MPY version. So in the moment, the current MPY version is version 6. The name of the library, say AOBLE, for example, and then the version. And then that will tell the board, here's what you need and where to put them. So for example, when you install AOBLE, you need to put this into this location, and this is the file you need. And then this is basically a content addressed file system, and so you can request files by their hash to ultimately file like that. Next one. And so that's the MPY file that it would have installed. So it's designed to be very, very simple, involve very small amount of data transfer. And another detail is that when you install a package, so AOBLE doesn't have any dependencies, but if I looked at, say, IJWT, the version includes all of its dependencies and the exact file hash at that version. So installing a if you install a particular version, you'll always get the exact same files no matter when you request that version again. So versions are sealed when published, including all of their dependencies. All right, that's about it. I guess the way that all this works in terms of publishing is on MicroPython lib, is that every package is in one of these three directories: MicroPython, Python ecosys, and Python standard lib. And so if we look at let's look at page 80 over here again, is that it has a manifest, and the manifest we can talk about another time, but the manifest is part of the MicroPython build system, and it describes Python dependencies for a build of the MicroPython firmware. But in this case, it's been used by the lib packaging system to identify same thing. It identifies Python files, but it picks them up and picks up their dependencies. So in this case, it requires the HMAC library. It includes this module. So the burden of publishing a library to MicroPython lib is quite small. You create a directory with the name of the package, put the files either directly as modules or in a directory as a package, and then the manifest.file itemize each file that is required and any dependencies, and make a pull request. That's the whole process. Cool. All I have to say about that.
That's really cool. Quick question: we use GitLab internally at work.
Yep.
How can we make this work?
Yeah. So the thing I showed earlier with installing via GitHub URL, this is really it's syntactic sugar for an HTTP request. So inside MIP, it knows how to turn a GitHub URL into a request to raw.github user content at a particular branch. So somebody could come along and implement if URL that starts with GitLab and do the exact same transformation. We could have not implemented this, and then it could have been slightly more awkward. We could have required, your installation instructions could be, you get the idea. But yeah, it's a simple transformation. As long as GitLab or any other thing that you can host content on support something like that.
Have to be a public repository then? Do you have a private repository with this work?
So we might be an idea to make these sort of extensions, Jim, because then we could register an extension for like an internal GitLab like we have. Does that make sense?
Yeah, I guess in theory we could have you could install mip-GitLab or something, and as an optional extension to MIP. And
well, I mean, it's something that we would need internally. Like it's not a public facing.
Yeah, I see what you're saying.
Repo. So like we probably wouldn't want to publish that into MIP. We need some way to configure MIP so that it knows, what our base URL is or something. Yeah,
that's a good idea. A default base URL. Yeah. You don't want to have to override that every time you do an installation. Yeah, that's right.
Yeah, that's really cool.
So will we be recommending that MicroPython library developers now publish them through MicroPython lib so that they're MIP installable? So for example, I recently suggested to the Pimoroni folks with their Few library that they make it UPIP installable and put it on pip. I'm just trying to figure out what the preferred path might be in the future using MIP.
The ideal is to put things in MicroPython lib, because then there's one place to go and they're curated and discoverable, all that stuff. And I realized that PyPy provides a similar service, but there is advantages to having our own namespace, and it lets us simplify a few things. What I want to do is, and so this has come up, we've been discussing with the author of Microdot, is I want to make something sort of a hybrid approach where you kind of maintain the code in your own repository, And then MicroPython lib becomes more of a registry of other repositories that we can fetch content from, and also do the MPY cross compile for you. So, you know, Microdot's a good example. The author of Microdot doesn't want to move Microdot into MicroPython lib, but we should still have Microdot be part of MicroPython lib. And so MicroPython lib becomes kind of two things. One, it's as a repository of projects that, in some sense, it's like projects that are being donated to MicroPython. Like, this is a thing I've written and it's useful to people using MicroPython, but, you know, is part of the MicroPython project. Lots of drivers, I think, fall into that category. But something like Microdot, like the author, you know, has a lot of more technical direction over it and you know, longer term plans for what to do with it. And so in that sense, MicroPython lib is much more like PyPy. It's a registry of known MicroPython packages. And very quickly, the rough idea there is that you would have a, for example, a directory in here, and instead of having the Python files, so like request.py sitting here, the manifest would describe how to get to the GitHub repository that actually hosts this particular library. And then when the server run that produces the MPY files and makes them all available to be downloaded by MIP, it would then follow that link and do all that for you. So yeah, it's a hybrid. It's a hybrid of both a place to put the host projects, but also to as a registry. I plan to implement that quite soon. Just haven't finished that yet.
That's cool. Anyone got any questions? Because I know, Jim, hope your kids aren't
No, that's all good. All good.
stuck outside. Do you see any other problems with MIP at the moment, or is it all clear sailing as you're concerned?
Well, I mean, technically MIP's not released yet because it's going to be frozen into 1.20. So I don't think, yeah, we haven't done any sort of release announcement or anything like that. So I don't think it's had much use yet. But yeah, ask me again after 1.20.
Cool. Okay. Maybe that's a nice segue into to Damien's talk then.
All right. Thanks, Matt.
Okay.
Thank you, Jim. Thanks very much for that.
Thanks, Jim.
And not just the talk, for the work too. Like, I know you've made it look really simple to use, but there's a crap ton of work in the background there. So thanks.
No, thank you. It's yeah, there were lots of alternatives here in terms of how we could have done this. The idea here was to make something that was very, very simple and very, very low overhead for the boards. And overall, I think it contributed a net decrease in firmware size.
Yes.
Compared to UPIP. So yeah, a bunch of extra functionality. You can install at particular versions. You get the MPY cross compile. The versions are sealed, and the same mechanism for publishing works for freezing as well. So yeah, thank you.